Hello. Hello. Today, talk about natural language processing. First, we're gonna use NLTK, which is typical library we're gonna use. Just import it and make sure you NLTK download. You wanna download all the packages down there. I already did that, so I just comment them out. Then the first concept is tokenizing. What tokenizing was looking for is actually split your sentence by either words or sentence. First thing you need is from NLTK tokenize import. There's two kind of tokenized method. One is sent tokenized or word tokenized. For example, expect text. If they have a text is how are you? I'm from China. I'm on Earth. This text we have, and let's just run this. And if you use the sent tokenize, and the input, you just put the sentence in there. They will separate. They will get a list, and all the list is every sentence is a list item. Okay, and a word tokenize is the other way to do. See here, it will get all the words, and also question marks, comma, periods, those things. And the other thing is, so you can get the pieces of your text. And the other thing is stop words, because in language there's words that's not useful. NLTK actually have stop words for it. It's from corpus. What corpus mean is actually the body of text, some like default text. So from early to corpus, you import stop words, and you can use stop words English. You can put Chinese or whatever other language they have. So it's stop words, dot words, and if we have a set for that, we could look at it. Let's just so these are all the stop words. You can see that a lot of them, like about, after, all, I am, all those words. These are all stop words, which means they don't have any meaning in there. So we could, for example, we could do words, which is these are all the words in our text. We could actually delete like R, am, those words, in stop words, which have no meaning, right? So I did list comprehension. We just W. We want to return W, and for W in words, if in the words, which is this list, for every W, if W is not in the stop words, we'll include it. So let's just run this and print them out, and you can see we have smaller information. Okay, like these words can still how, I, China, I, Earth, I eat, noodles, morning. So it still have some meanings, essential content meanings in the sentence. All right, so pretty cool. The other is stemming, which means normalized words, because in words we have different words. For example, proto stammer. You want to from stem. You want to use proto stammer. It's a method, so you want to introduce it in the code. So let's say ps equals proto stammer, and then you could, for example, like write, writing, writer, writes. It's kind of the same meaning. Those lists. So you could actually I just use the map method, and I use a method which is ps dot stem, and you put down the every single item in there. So and we could run. So we run. You can see here you get a write, writer, write. So all this writing change to write, writes change to write. So it's the essential things. Okay. You can also print individual ones like writing, like making, okay, and see what's that was. See here, it's making is make, okay. Okay, the other thing is lemmatizing. It's similar to stemming, but it's just faster way to do. You know, it, for example, cats. You know, you need to use the. It's still from stem. It's from WordNet Terminizer. Okay, it's just two different sources. All right. This is from Porter. This is from WordNet. Okay. Um, and you know, still you introduce it, and then you use a method called lematize. Okay. For example, cats. You know, we'll get cat. Writers. You'll get a writer. And better, make sure its position is A. Position A means you will get the you know, base term. For example, you get it? So that's good. Better is good. Okay. So if I change this worse, your turn to bad. Right. So that's stemming and lemmatizing. Then is WordNet corpus. Okay, WordNet is like a dictionary. It's actually very powerful. For example, some words you can get the meanings, definitions from it. That you wanna import the WordNet, and there's method called synsets. What synsets you do is you can get the definitions of others, meanings of this you know, the meanings of this word. So if I click it, sings, let me print it. So you can see here, the program have all this kind of meanings. Okay, it's like sings, it's program number 2, which means is plan number 1, which means the first definition is a plan, is a long, and the second is a program, and the third is broadcast. You know, and second, it can be means a platform. It can be a, you know, program. It's another meaning. Okay, so then for each meaning, for example, since 0, it should be the first one, the plan. You can actually get the use the namas methods, and you can read the. You know, you can, for example, let's do that. So you see here is plan, which means it will, you know, don't include the long 0, 1, which is, you know, this different type of word. There's numbers, different numbers of the meanings in the whole list. So, you know, you'll get the name, you know, namas, which is a plan. You will get the, you know, the first word, which is the namas, right? And get the names. Okay, make sure it's 0. It's 0 on namas also. So that's how you get names. And also you could get, for this is the first one, you could get the definition. Okay, a series of steps to be carried out or goals to be accomplished. Okay, this is the definition of the first meanings. And you could, you know, get an example even. You know, this is an example sentence of, you know, the first meaning. Okay, you can get second one also. The other cool thing is you can get the synonyms or antonyms. For example, synonyms, which is a similar meanings. You could use this. You can for all the synsets of bad, which is all the individual synset meanings definitions. You choose one, which is the first one, which is like you know, like this synset 0, the first one, and on this first one we want to get namas. Namas is actually inside here. Okay, and then you get the, you know, let's just print. You know, print them. I use format string here, which means I want to print a string, and the string is actually the air, which is the first of the namas. And also, you know, I can create a list for that, and then you know, you want to get antonyms. Because some words don't have antonyms, so you want to print, L, this time is different. You wanna antonyms, use this method. Make sure it's the first names. Is the elements in the names, and you get the first one, and you get names. Okay. Yeah, let's print out and see what it was. Okay, so you get all these words. So you can see here, this is synonyms. So it's bad, and the antonyms is bad. It's good. Okay, this is bad. This is goodness. Okay, so it's different ways of looking at it. However, the best way is still use this one, which is similarity of words, because these two words are similar. You can know whether they're antonyms or not antonyms. For example, if you wanna, the first word is word net syntax region. Just make sure you wanna get a syntax first. Okay, it's actually compare the elements of syntax. Okay, so the definitions of syntax. Okay, it's not actually just directly compare two words. Okay, you want to get the syntax first. So did you get the syntax of the region and get syntax of site, and we could use this whoop similarity, and you could actually calculate the similarity of them. So it's kind of similar. And cat and sheep, let's calculate it. So it's 0.3, which is not that similar, but you can change the this is all first meaning. You can change second. It's not even that similar again. So that's the case. See here. So if it's bad and good, which is the opposite, let's just run it. However, some words doesn't work. For example, nice and excellent. If you do it, you'll get along. And if it's good and bad, for example, good and bad, if you get the similarity of it, you'll get 0.6. Which means these two words are most time means similar things. Okay, it may it's opposite but similar descriptions on something, right? So that's this. I will see you next time.